Our objective is to solve radical equations. These will have some advanced forms of them where you have to do some extra techniques, sometimes repeating steps in order to get to your final result. But most of the time you just follow the same steps. You just might have to add some extra steps in the process. So in this first one, our first step is isolate the radical. So we're going to go ahead and add the square root to both sides. So we'll get x equal to the square root of 2x plus 15. And we do the same process of squaring both sides. So you get x squared and the square root will be gone. Just leave you with the radicand, 2x plus 15. Now we subtract 2x from both sides, subtract 15 from both sides to get 0 inside because we're going to solve this quadratic. I'll factor to solve this one. So you have in the process here two numbers that multiply to get negative 15, add to get the negative 2. Well, that would be a negative 5 and a positive 3. So x minus 5 equals 0. So x equals 5. And then x plus 3 equals 0. X equals negative 3. Now we still have to check our answers, and with these advanced forms, there's many cases where you will have extraneous solutions. So to do the check, I'm going to do it and label which one I'm checking. I'm going to check x equals 5 first, put it back into the original. Is 5 minus the square root of 2 times 5 is 10, so 10 plus 15. Does that equal 0? Well, this is 5 minus the square root of 25. That does equal 0 because it's 5 minus 5. So this is a solution. Let's try now x equals negative 3. So you put that into here and you get negative 3 minus the square root of 2 times negative 3 is negative 6. Plus 15, does that equal 0? Well, if we have negative 3 minus, this is the square root of 9. When you do negative 3 minus 3, you get negative 6. That is not correct, so negative 6 does not equal 0. So x does not equal negative 3. So our only solution for this one is 5. Let's try the next one. Now this one has 2 square roots in the problem. You still follow the same guidelines. You want to get one of the radicals by themselves. So that to get one of these square roots by themselves, I'm going to add this one to both sides. Now notice that actually gets both of them by themselves on each side. So this is one type that you'll get just both sides will have a square root on both sides. You still square both sides. That will eliminate all the square roots in this case. So you're going to have 12x minus 26 equal to 10x. You go ahead and solve by subtracting 12x from both sides. You get negative 26 equals negative 2x. Divide by negative 2 and you get x equal to 13. I'm going to go ahead and put that into a check to see if it's extraneous or if it's actually a solution. So does it equal the square root of 10 times 13 is 130 minus the square root of 12 times 13. Let's go ahead and do that on our calculator. 12 times 13 gives us 156. 156 minus 26, which equals the same thing. So square root of 130 minus the square root of 130, that checks. That would be a 0. You get 0 equal to 0. So that one checks out. Our answer then is just 13. Now let's do this last one. This last one's going to involve extra steps. So you got to be careful that you follow through and are very patient in doing these types of problems, especially when there's a radical on both sides, but also there's something outside of the radical. This is going to cause us to have the extra technique of repeating the steps. So the first thing, get one of the square roots by itself. It already is. So since it's by itself, I'm going to square both sides to get rid of the square root. So x minus 9 is going to equal, now this side, if I square this side, this is the technique I'm using, that means I've got to multiply it out. it doesn't get rid of the square root. Instead, it causes us to do some algebra of the double distributive. So I'm going to multiply this times this. So over here I still have the x minus 9. When the radicands are the same, the square roots disappear because it's this and this multiplied together is squared, and so I end up with just 2x plus 14. Okay, I'll put it in parentheses just to represent it was these two multiplied. I'm going to multiply this one times that. I get negative 4 square roots of 2x plus 14. And I multiply this one by it. I get negative 4 square roots of 2x plus 14. And then lastly, the negative 4 times negative 4 is plus 16. Let's go ahead and gather like terms together. So x minus 9 equals 2x, it's all by itself. 14 plus 16 will give me 30. And then minus 8 of these square roots of 2x plus 14. Notice that those two can combine, you can combine the coefficients. Now, notice that my new equation here has only one square root to it. So now I can follow that same technique of, again, getting the square root by itself. So this is where you have to repeat it a second time. So we get this square root by itself. So I'm going to subtract 2x from both sides, I get negative x. I'm going to subtract 30 from both sides, I get negative 39. And then over here I'm going to get negative 8 square roots of 2x plus 14. Now I'm going to go ahead and divide by negative 8 on both sides, so you get negative x minus 39 over 8, negative 8, equals the square root of 2x plus 14. I'm going to be a little easier on myself here. I'm going to go ahead and, this fraction, I'm going to multiply by negative 1 over negative 1, just to get rid of the negative in the denominator. So I'm going to make this x plus 39 by multiplying both of them by negative 1 over 8 equals the square root of 2x plus 14. Now you've got to square both sides to get rid of that square root. Squaring this side gives me just the 2x plus 14. Over here, I square the numerator, and I'm going to have to do, again, this is going to be like doing x plus 39 times x plus 39. Let's go ahead and do that. I'm going to multiply x and x. I get x squared plus 39x plus 39x. And then plus, I need to do 39 times 39. So 39 times 39 gives me 1521. So plus 1521. So I've got in this numerator x squared plus 78x, and then plus 1521, all over 8 squared, which is 64. So remember, I squared the whole side. I have to square the numerator. I did over here. 8 squared is 64. I'm going to, again, be a little easier on myself. I'm going to multiply both sides by that denominator to get rid of it. So I'm going to have x squared plus 78x plus 1521 equals, multiply by 64, it'll be 128x. Multiply this by 64, I need 14 times 64. So 14 times 64, that gives me 896. And so now I'm going to bring everything over on this side to solve that quadratic. So x squared, subtract 128x from both sides. So subtracting 128x from 78x, that's going to give me a negative 50x. And then subtracting, let's see, 1521, and I'm going to subtract 896 from that. So 1521 minus 896, and I get 625. So let's make that a positive 625. Now that equals 0. Now I have to either factor this, I could use the quadratic formula, I could use completing the square. What I recognize though is 625 is 25 squared. and 50 is 25 plus 25. So this factors into x minus 25, x minus 25, which equals 0 if you spot that. So x minus 25 equals 0. So x equals 25. And x minus 25 equals 0 gives you the same answer. So you only get 25 as an answer. Now I've got to go back and check my answer. Let's do a check over here. Let's see how this works. I've got the square root of 25 minus 9. Does that equal, putting it in here, the square root of 2 times 25 is 50, plus 14 minus 4. Does the square root of 16, does that equal the square root of 64 minus 4? Square root of 16 is 4. Square root of 64 is 8. 8 minus 4 is equal to 4. That checks, so my answer is this 25. So this advanced form here, if you've got multiple square roots and a number outside, you might have to go through the process of repeating your steps in order to get to that final answer.